Climate change demands action. Who is demanding action? We are. The coming generation. Our world will not be like yours. You've already changed it. We are depending on you. When I first put the slide together, I saw those pictures, and I said, those look like my grandchildren. Well, these are my grandchildren. These are 4 of my 6 grandchildren. But the message really came home to me. These kids are young. Many of them, several of them, will live until the year 2100. You'll see in the projections coming forward what the world might look like by the end of this century. All of us gray hairs and no hairs won't be there, but these guys will, and I care about that. That's why I'm here. Okay, I want to give you 4 characteristics of global warming, 4 of the fingerprints of global warming. The first is a temperature chart. This is an average world temperature for the last 130 years. It's an average of thousands of data points taken every year, taken every month, taken every day. And you can see year to year, it bounces along. But you can also see that there's an increasing trend here. If you look at the average temperature, it's about 1 degree centigrade higher than it was in the pre-industrial revolution. 1.8 degrees Fahrenheit in our language. And you say, what's the big deal? What is 1.8 degrees Fahrenheit? The best analogy I can come up with is a fever. Okay, our temperature, our body temperature is 98.6 or so. If you have a 2-degree fever, you feel it. You feel pretty crummy. You may not be able to go to work. And all the systems feel it. Your head doesn't work right. Your gut doesn't feel right. You got body aches. Fever's important. Same thing with the complex systems of our climate. You raise the temperature, things change, things don't work right. This is that same data, but the bottom curve is a decade average of it. So you take all 10 data points for the decade and you put it on as a line. Look at the right-hand side of that curve. Step, 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 step. The last 40 years, we have had significant increase in temperature, and it's accelerating. If you look at the top curve in the upper right-hand corner, I've plotted the last 4 years. 2014 was the hottest record, the hottest temperature on record until 2015. Now, part of that increase has to do with El Nino, okay? But the trend line continues. Global warming has not stopped. The next fingerprint is that of sea level rise. This is the last 45 years of sea level. The red is done with tidal gauges. The blue has superimposed on it satellite observations. That's about 8 inches of sea level rise. It's also accelerating. Why does the sea level rise as the Earth gets warmer? 2 main factors. First is it's just a thermal expansion of the ocean waters. Okay, you heat something up, it gets bigger. That's what's happening. The second is the melting of land ice. If sea ice doesn't affect it because it's already being supported by the ocean, land ice, glaciers, Greenland, Antarctica, as those ice mountains, continents melt, that water goes into the ocean and it raises sea level. That also is accelerating. About half of it is from thermal expansion, half of it is from melting of glaciers and land ice. The third characteristic is the melting of the ice cap on the Arctic Sea. Now, it's a little bit tricky to do because every winter, when there's no sun and it's 20, 30, 40 degrees below zero, it all freezes over. In the summer, the sun comes out all day and the ice melts back. So you take your data point at minimum ice, September of the year. So this is 35 years of sea ice. And you can see that the parameter there, it's in millions of square kilometers, has gone from 8 to below 4 in 35 years. That parameter has changed by a factor of 2 in 35 years and is continuing. Now, what do we care? I mean, what do we care how much ice is on top of the North Pole? 2 reasons. One is that it changes the reflectivity of that region. If you've got ice, 80% of the sunlight coming in gets reflected back out into space and doesn't warm the Earth at all. If you've got open water, 80% gets absorbed and only 20% gets reflected back. So it's a self-feeding mechanism. It's changed the reflectivity of that region. And it was started by increased greenhouse gases, but it is on a roll of its own now. The second reason we should care is it affects our weather. The average air temperature above the poles increase more than any place else on Earth. The increase from its normal, like 8 degrees above normal from historical. And that changes our weather pattern. The jet stream is driven by the temperature differential between the equator and the poles. As you decrease that temperature differential, the jet stream changes. And it begins to slow down and wiggle. And one of the things that we enjoyed in Wisconsin is that Arctic thrust that we had several years ago. And it continues to adjust our weather pattern. I want to make one point. Weather and climate are not the same. Weather is what we see today, next week, next month, or over the year. Climate is what we see over 30, 50, and 100 years. Mostly what we talk about here tonight is climate, large-scale, long-term changes. The fourth characteristic is that of atmospheric carbon dioxide. Now, the first 3 you can go out and observe. This one you need a chemist to help you with. The squiggle on the red line is the seasonal variation of carbon dioxide in the atmosphere. And that has to do with the normal cycle of carbon dioxide. All life on Earth is dependent on the carbon cycle. In the summer, in the northern hemisphere, photosynthesis takes carbon dioxide and water and sunlight and produces hydrocarbons for us. Food for us, food for animals. And in the winter, that photosynthesis slows down. So in the summer, carbon dioxide goes down. In the winter, carbon dioxide goes up. If everything was in balance, one spring would look just like the last spring. The carbon dioxide in the atmosphere would be exactly the same. But let's look at the curve. You can see the wiggle on there. But over the last 55 years, the carbon dioxide in the atmosphere has gone up by 25%. And it goes up by 2 parts per million every year. All right. How's that happening? Why is it continuing to go up? It's because we're digging up long-buried fossil fuels and we're burning them. And when you burn a fossil fuel, it creates carbon dioxide. So, what do we want to do here? Excuse me, my phone is buzzing. The hydrocarbons are dug up, they're burned. Portion of that carbon dioxide goes into the ocean. It unites and makes acid in the ocean. It's called ocean acidification. It takes it out of the atmosphere. Good for the atmosphere, not so good for the oceans. Part of it goes into the land and the trees, 45% of it goes into the atmosphere and stays in the atmosphere. And how long does it stay in the atmosphere? 100 years? 1,000 years? 10,000 years. Okay? The time constant of carbon dioxide in the atmosphere is much longer than our lifetimes and much longer than our society's lifetime. The carbon dioxide that we put out to get here tonight, some of that is going to remain in the atmosphere for the next 10,000 years. It doesn't go away. When I learned that fact, I was shocked. I didn't believe it. I looked at it again. I looked at the chemistry. It's true. It doesn't go away. The way you can get rid of some of it is plant some more trees. Okay? As a society, we're not doing that. We're cutting down the rainforests. Okay, here's the footprint. Increased temperatures, increased carbon dioxide in the atmosphere, decreased sea ice, increased sea level. These are 4 what I call the footprints. These data are not controversial. They're accepted by everybody. Nobody says that none of these are not real. Now, the one piece that I haven't done, why did I put carbon dioxide up there? And that has to do with the greenhouse gases. And let me talk about that for just a minute, so you get a feel of why. This is a science that's been known since the late 1800s, that there is a characteristic called greenhouse gases. The Earth has carbon dioxide in the atmosphere, and it's necessary. If it didn't, our planet would probably be too cold for us to live, for humans to prosper. That correct level is about 280 parts per million. Because of the carbon we have dug up and put in the atmosphere, that level is now over 400 parts per million. It's like putting 2 more blankets on the bed. Okay, and they're there, and we don't know how to get rid of them. So you put too many blankets on, stuff gets hot. Stuff warms up. Scientists are still debating the causes of global warming. You're right, you're a minority. Most people say the scientists are still debating it. Let me give you some information. No, it's not. It's general knowledge. It's television. It's television what does it. You have a talking head A that says, the scientists have a clear picture. You have talking head B that says, oh, we're not really sure. Let's look at some facts. This group went back and it looked at the scientific peer-reviewed publications about climate change from 1991 to 2011. 1,200 papers to determine what the authors acknowledged as the validity of human-caused global warming. How many accepted that? How many rejected it? And here is how the answers came out. On the left side are the authors that reject that notion. On the right side, on the left side is the authors that acknowledge it. On the right side, rejected. On the left side, acknowledged. Okay, the number of authors of all of the 12,000 papers, 124 reject the idea that human causes of global warming. We're still going here, and we got 368 authors that accept it. But I don't know if you noticed, that was just the A's. All of the authors are listed in the rejected column. The A's are in the, okay, so let's look at the B's. And since we are running a little late, I'm going to speed this up. 671. So there's, right now there's 1,000 to 124. Let's look at all of the authors. And we'll sum those up. 10,000 of the authors of these peer-reviewed scientific papers on, from the environmentalists, from the biologists, from the physicists, 10,000 say it's human cause of global warming. There's 124 that reject that idea. 99% to 1.2%. This is the strongest scientific consensus that you will find in any area of science. This is over a 20-year period. And if you look at the progress of that, the current papers, there are none that reject the idea that it's human caused. There's one other way I want to show that to you, just so you'll get a visual picture of what that looks like. The dots on the left are 10 authors that say that human caused global warming. On the right, the dot is the 10 authors that reject that idea. All right, there's a visual image. The best consensus that you've ever seen in terms of science. Scientists love to debate. They love to talk. They love to argue. They love to be controversial and deniers. It's gone from here. You can still ignore the 99% and believe the 1%. But please, do not declare that scientists are still debating global warming. They're not. They're not. All right, it's something new. This is a 6,000-year trail of carbon dioxide in the atmosphere and global temperature. Now, the first question is, how in the world does Steve know what the temperature, what the carbon dioxide level was 6,000 years ago? What you do is you dig up ice cores. You go to Greenland. You go to Antarctica. And you bring up this great big ice core. And it's kind of like rings on a tree, but they're going down rather than around. And you can sample, micro-sample those, and you can tell what the carbon dioxide level was in the atmosphere 5,000 years ago or 2,000 years ago. Now, I've added a few of our Catholic friends here on the bottom. You've got St. Francis at year 1,000. You got Jesus at the year 0. You got David at 1,000 BC. You got Moses at, what is it, 1600 BC. So those are that was the carbon dioxide that was in there. So now, everything is kind of normal until you get way over to the right-hand side. Look at what happens to the blue line after it crosses the dotted line. The dotted line is the Industrial Revolution. It spikes up. This is old data. It's not up to 400. Today it's over 400. The red line has shown a constant decreasing in temperature, slow decreasing. We were entering into a new ice age. And it's, you look at the planets and you look at the orbits and you look at the tilt of the Earth, you'd expect that to be happening. But again, look at the right-hand side, spiking up. Carbon dioxide precedes the temperature. This 400 parts per million, what will it do to the temperature? Okay, there's also people that say, well, what about the glaciers? The climate has been changing all the time. Here's 1,000,000 years of data. Each of these bumps in here is an ice age. Each of these bumps is when a glacier came down and covered up Wisconsin. But look at the range that the carbon dioxide was under. It really, for all the last 1,000,000 years, it was really between 200 and 300 parts per million. And again, look at the right-hand side. We're up at 400. It's spiking off the chart. We haven't seen anything like this in terms of carbon dioxide in the last 1,000,000 years. Where's this carbon dioxide coming from? It's coming from the industrialized world. It's coming from the United States. This is the cumulative carbon dioxide production from 1900 to 2002. Now, how do we know that? Well, carbon is money, and there's really good records of how much is dug up and been burned. So we know. The U.S., the United States of America, in that 100 years, has produced 30% of the carbon dioxide that's in the atmosphere. China and Russia have produced under 10% in that period. Now, to be fair, China is now producing more carbon dioxide than we are in the United States. However, the per capita output of the United States is still 3 times higher than the Chinese per capita output. Oh, I've got to do one more thing here. Maybe I can go backwards. If you'll notice, the northern hemisphere gets the dark colors. The southern hemisphere produced very little carbon dioxide over that time period. 0.1% for countries. Ours was 30%. Okay, where's it coming from? The basics. Okay, we're converting long-buried fossil fuels into greenhouse gases at a rate the Earth has never seen before. That's from our power generation, our transportation, and our industries. That's global warming. What I've talked to you about up to this point is global warming. There's another term that's used interchangeably sometimes, and that's called climate change. Now, you look at the dictionary and you look at the definitions. These two terms are used interchangeably. I've chosen my description that what I've just shown you is global warming. And that's the fever. The climate change is the consequences. And you can use these terms pretty interchangeably, but for our discussion tonight, that's what I'm going to be talking about. Global disruption is another piece that's being used. And we're going to go through these really pretty quick because I'm running out of time, and we really want to run through it. The weather is one of the consequences. More energy and more water vapor in the atmosphere changes the weather. It gives us stronger storm surges, more flooding, more deeper droughts. Now, how do you get both of those? Well, it depends on where you live. If you happen to live in the Southwest, where a little bit of increase in temperature is going to significantly change evaporation rates, that's going to increase droughts. If you're there and it changes the weather patterns a little bit, where you get a little bit less rain, it's going to increase droughts. Forest fires, because things are drier, even massive snowstorms. If you got a big snowstorm, you really have more energy, and if it's below 32, you're going to get a lot of snow. Ice, melting of the Arctic, we talked about that. Changing of the reflectivity, we talked about that. Changing of the jet stream, I referred to it. Rising in sea level, changing in ocean currents. In addition to changing the jet stream, it may also change the ocean currents. Ecology, it is leading to extinction because animals and plants cannot change at the rate that the climate is changing. Changing in pests and pathogens. Mosquitoes coming farther north. Agricultural losses, allergies. People. People is my big card. It's our big card. It's the church's big card. But they're also very interested in the climate because you can't really distinguish creation from humanity. We're integrally related. We draw on the health. This is a chart I'm going to go through very quickly. This is from the World Bank. The colored here has to do with the pain that's caused by climate change. And you can see that it's almost all in the southern hemisphere. And the reason it is that way is because they have less, they're poor countries, and they have less ability to modify their lifestyle. Chart I showed you before, where the carbon comes from, the chart on the bottom, who's being affected. The church speaks out very loudly about this. Those that are causing the problem are not the ones firsthand that are suffering from the problem. I can't leave the science section till I said, let's look forward a little bit. The left-hand side of the graph is the last 100 years. and this is increased temperature rise. The right-hand side of the curve is the projections that are made at different universities, different government institutes. There's a lot of range of what the answers are. And they're grouped there. Now, there's 3 different colors, and that has to do with the path that we choose on how much more greenhouse gases we're going to emit into the atmosphere. The yellow on the bottom was if we could have stopped, held the greenhouse gas levels at the year 2000. We didn't. We blew right by it. So you can ignore that. We missed that one. The black X, just to the right of 2000, that's where we are today. The blue is if we have a low carbon future, and the red is if we have a high carbon future. All the way over on the right, there's a dot about at 8 degrees temperature increase. Okay, go back to the analogy of the fever. Right now, we're looking at 1.8 degrees. If we get another 8 degrees, what do my grandchildren have in terms of climate disruption? The Paris Peace Accords, which we've heard a lot about, they provide the dot at 4 degrees. This is the pledges that have come in. If we enact them, that's the best guess at what the temperatures will do. The Paris Peace Accord is asking for a goal that's in red, and the goal of 2 degrees Celsius, and the one below that is the 1.5 degrees. It's a little bit hard to see. This is ocean sea level. It's 125 years on the left to where we are today. You can see there's an X of where we are today. Over on the right-hand axis, there's a blue fan that goes out on the different models that are shown. The 2 degree centigrade X is sitting there. We're talking about an additional 30 inches of sea level rise. 4 degrees C rise, which is a little bit more than the Paris, we're talking about 40 inches. The latest information that's coming from the studies of Antarctica and Greenland say that these did not contain some new mechanisms. It could be 1 or 2 feet higher than this. So we could be talking anywhere from 4 to 8 feet increase in sea level rise by the end of this decade. Pope Francis talks about this. He says that there's over 1 billion people that live close to the ocean. This is a big deal, a real big deal on human disruption. The path forward. This is James Hansen. He's a NASA scientist. Those are the guys who put men on the moon. He was in charge of the Goddard Labs for 25 years, and he was in charge of climate science. The blame, if we fail to stand up and demand a change in course, will fall on us, the current generation. Our parents honestly didn't know that their actions could harm future generations. We, the current generation, can only pretend that we don't know. This is the face of climate change. This is the face of global warming. Questions about the science, questions about the morality.